This is our last recitation. So recitation 14. So the first one is graphing. Write down possible expressions for this graph. So this graph is for function, polynomial function. And this we can mark with this. So with this, we know the degree is even. So the n behavior tells us the degree is even. Then let's count how many wiggles. So I have 1. So this 1 represents degree 2. Then this wiggles degree 3. Then this again. So 1 plus 3, 4, 5, 6. So n should be 6. So degree 6 polynomial. Then we see this goes through 0, 0. So that means our function has x as a factor. So maybe a, x, then let's see other roots. So 0 has a degree 3, right? Multiplicity of 3. So we have x cubed because this wiggles at the origin. Then we see this goes away from x-axis, right? And this touches x-axis. That means x minus 6 with multiplicity of 2. So this is a 2. So now let's see. So we have no more roots, but so this one we see goes away. It doesn't touch x-axis. That means we have a complex roots there. Maybe like x squared plus something, right? But you know, we don't need to find the exact. We need to find the possible expressions. Just one possible functions. So here we have degree 3. Here we have a degree 2. Then, because we know degree is 6, so we just need one more. One more. So this way goes, oh, we have this root, almost forgot. You see this? X plus 5. Okay, let me rewrite this. So it's f of x. I don't know why this like that. Equals to, well, this is 0, so let's say a is 1. We have x raised by 3, x minus 6 squared, x plus 5. Excuse me. So this is the one possible function for this graph. Okay, you see the origin, right? 0, 0. If x equals 0, so this is 0. 0 times anything will be 0. And it's a polynomial degree 6 degrees, so 3 plus 2 plus 1, 6 degree 6. And we have roots of negative 5, that's x plus 5. We have roots of 0 with multiplicity of 3. We have roots of 6 with multiplicity of 2. Let's see, B. B, we know this is a rational function. Rational function means we have a polynomial in the numerator, we have a polynomial in the denominator. And this tells us we have an odd degree, right? You see this one in the first quadrant, this one in the second quadrant, and this middle. And also we see this vertical asymptotes. Excuse me, I have allergy. X equals a negative 3 is a vertical asymptote. X equals the 4 is a vertical asymptote. So that means the denominator will have two factors, x plus 3 and x minus 4. So those two factors in the denominator. Excuse me. And the numerator, so then we see this one in the first quadrant, this one in the second quadrant, And we see, I think this 1, 0 is on the graph. 1, 0 in the graph. So that means when the function is 0, when x value is 1, the function is 0. That means our numerator is x minus 1. Because when x equals 1, 1 minus 1 is 0. 0 divided by anything will be 0. Right? So we get this 1, 0 factor. So this could be just one of the possible functions for this graph. Now let's see question 2. This is inequalities. So first we focus on the sign. The sign is saying greater than 0, positive. This one is always positive because it's a square. So this one always positive. So you can just leave this alone. Forget about this. Just consider x plus 5 times x minus 4 raised by 3 greater than 0. Okay, now we can do this. We can draw the real number line. Draw -5. Draw +4. So let's just pick a value because this divides into 3 intervals, right? This interval. Then from -5 to 4. Then from 4 up to +infinity. So 3 intervals. So consider these 3 intervals from -infinity up to -5. Then from -5 up to 4. Then from 4 up to +infinity. So in each interval, we pick a value. So this one, in the first interval, maybe we'll pick a -6. So if x equals -6, we get negative for this one. X -6, we get negative for this one. Bingo, negative times negative, positive. So that means this interval is in the solution set. I'll pick one from the middle one. Well, let's pick 0. 0 plus 5, 5, positive. 0 minus 4 raised by 3, negative. Positive times negative cannot be positive, cannot be greater than 0. So this won't be in the solution. Then maybe we'll pick 5 from this interval. So 5 plus 5 is 10, positive. 5 minus 4, 1, positive. Positive times positive, positive. So this is the solution. So the solution for this one is -infinity up to -5, union 4 up to infinity. Okay, so these 2 intervals in the solution set. Let's see B. So B, we want to solve this trig equation. We have sine of 2x, the angle is 2x, plus sine x equals to 0. So sine of 2x, remember the formula is 2 times sine x cosine x. So that plus sine x equals to 0. Sine x, so sine x is a common factor. So let's factor out sine x. Then we have 2 cosine x plus 1 equals 0, right? Then by 0 property, the factor sine x can be 0. 2 cosine x plus 1 can be 0. So sine x equals 0, that means x equals 0. The angle, because sine 0 is 0, and sine pi is 0, right? So we have 2 solutions. Because we're looking for the solutions from 0 to 2 pi, but not including 2 pi. Then this one, we got 2 cosine x equals to -1. So cosine x equals to -half. Well, cosine value to be negative is in the second quadrant and the third quadrant, right? Cosine to be negative. And a half means the angle is 60. cosine value. The reference angle is 60, because the cosine 60 is half. But because in these two quadrants, so we get negative. So what is the true angle of this one? 120, right? So x equals to 120 degree. Well, 60 is pi over 3. So 120 is 5 pi over 3. And this angle. This angle is pi plus pi over 3, which is a 4 pi over 3. Okay, so total I have 4 solutions. 0 or pi, 5 pi over 3, or 4 pi over 3. Okay, we want to find all roots for this polynomial degree 4. Remember rational roots theorem, saying all the possible roots of this comes from the factors of the constant term divided by the factors of the leading coefficient. The leading coefficient in this case is just 1. So the possible roots. Plus minus 2 divided by plus minus 1, which is a plus minus 2. And the plus minus 1 divided by plus minus 1, which is just plus minus 1. Right, so let's use a short division to do that. Short division, we only take the coefficient of each term. So 1, 3, -7, -7, and 2. Well, let's try positive 1 first. So we'll pull this one down. We multiply 1 and 1, we get 1, we put over here. We add those two, get 4. Then 1 times 4 is 4. We add those two, get -3. 1 times -3, -3. We add those two, get -10. 1 times -10, -10. So we add those two, get -8, which is not 0. So that means 1 is not. 1 is not. Well, let's try -1. Let's erase. So let's try -1. We pull this one down, -1 times 1, -1. Add those two, get 2. -1 times 2, -2. Add those two, -9. -1 times -9, positive 9. Add those two, -2. -1, -2, positive 2. 2 plus 2, 4. Is still not. So plus minus 1, not the roots. So now let's try positive 2. Let's try positive 2. So 1 times 2 is 2. Add together, 5. 2 times 5, 10. Add, positive 3. 2 times 3, 6. Add, -1. 2 times -1, -2, bingo. 2 plus -2, 0. So that means this can be written as x minus 2. Now let's see. Now let's see if -2 is a root. So -2, so this is negative now. -2 times 1, -2. Add together, 1. So -2. Add together, -9. Positive 18. Add together, positive 11. Too big. So -2 is not. It's not. All right. So I have tried all possible. So now, so we can write this one as, oh, I erased it. X minus 2 times something. Because we need to find all the roots, even complex roots. Let me do one more time. So I have 1, 3, -7, 2. We find out 2 is 1 root, right? Because 1, 2, 5, 10, positive 3, positive 6, -1, -2. So this is we have x cubed plus 5x plus 3 plus 5x squared, 3x, then -1. Right, so this shows quotient. So x minus 2 times x cubed plus 5x squared plus 3x minus 1. Right. Looks like only one real roots, but also we need to find the complex roots. Well, let's try one more time. So we have 1, 5, positive 3, -1. Yeah, we tried the one before, it's not, right? Let's try one more time. Maybe sometime I make mistakes. So 1 times 1, 1. 5 plus 1, 6. 1 times 6 is 6. Add together 9. That's too big. So 1 is not. Let's say -1. -1, -1. 5 plus -1, 4. Then -4. So -1. Oh, yes. Then positive 1. So we have x minus 2 and x plus 1 times x squared plus 4x minus 1. All right, almost done. The last one is x squared plus 4x minus 1. We can use quadratic formula, right? Quadratic formula is we can factor as x equals to -b, which is -4 plus minus 4 squared, which is 16, minus 4 times -1, a is 1. Then divided by 2 times 1. So -4 divided by 2, that's -2, plus minus -4 times -1, positive 4, 16 plus 4, 20. Square root of 20 equals to 2 radical 5. Because 20 is 4 times 5. Square root of 4 is 2. So 2 divided by these 2 is 1. So plus minus square root of 5. Okay. So we find our roots. So our roots have 2, -1, -2 plus radical 5. And -2 minus radical 5 for roots. Let's see B, use binomial theorem, expand this. So degree is 4, right? So we can construct Pascal's triangle. Start with 1, 1, 1. Add this one, we get 2, 1. Add those 2, get 3. Add those 2, get 3. This is degree 0, this is degree 1, degree 2, degree 3. So we need to do one more layer. 1. Add these 2, have 4. Add these 2, I get 6. Add these 2, get 4. And we get a 1. So those are the coefficients of each term. So we have x raised by 4, right? Because it's degree 4. This first term. Then plus the second term will be x raised by 3 now, because the first term goes descending order. The exponents of the first term goes descending order from 4, 3, 2, 1, then 0. And the second term goes ascending order, the exponent. You see in the first term, 5y is a 5y raised by 0, is 1. But now it's a 5y raised by 1, just 5y. Then the third term would be x squared times 5y squared. So each term has degree 4 in total. See, this is degree 4. Degree 3 plus y, degree 1, that's degree 4. X has a degree 2, y has a degree 2, that's degree 4. Then x times 5y raised by 3. Then in the end, x raised by 0, which is just 1, but the 5y raised by 4. Now let's multiply those coefficients. So the first one, just 1 times this. Second one is 4. Maybe I should use red color. So the coefficient of second one is 4. Coefficient of third one is 6. Then this one is 4. Last one is 1. Then we can clean this up. So we'll get x raised by 4 plus 4 times 5, 20. 20 x raised by 3 y plus 6 times, so this 5 squared is 25. 25 times 6, 150. 150 x squared y squared. Then plus 4 times 5 cubed. 5 cubed is 125. 4 times 125 is 600. 500. Right? Because 4 times 25, 100. 100 times 4, 400, 500. So we got 500 x y cubed. Then the last term is 1 times anything will be anything. So 5 raised by 4. That's 125 times 5, which is 625 times y raised by 4. Okay. So this is a binomial expansion by binomial theorem. So first you construct Pascal's triangle by doing this. That becomes the leading coefficient of every term. Then you think the first term goes, the exponent of the first one goes descending order. The exponent of the second one goes ascending order. Okay, let's see 4. We want to find the sum of this geometric sequence, right? How do we know it's a geometric sequence? Because we see 2 raised by k minus 1. If we think this as a function, so this is exponential function. So geometric sequence sum Sn equals to A, the first term, times 1 minus the common ratio raised by n divided by 1 minus r, right? This is the formula. So we need to figure out A1. We need to figure out n. We need to figure out r. 3 variables. So what is the A1? A1, k, the index start with 6. So A1 equals to 54 times 2 raised by 6 minus 1. Big number. So 54 times 2 raised by 5. Well, let's just keep it as this. So hopefully in somewhere we can simplify 54 times 2 raised by 5. What about n? N is, the upper limit is 11. Lower limit is 6. Then add 1 back. So 11 minus 6, that's 5. 5 plus 1, that's 6. So n equals to 6. Now common ratio is 2, right? That's obvious. Common ratio is 2. So we have these 3 values. Now we plug into this formula. So this formula is S6 equals the first term, which is 54 times 2 raised by 5 times 1 minus r raised by n, which is 2 raised by 6 divided by 1 minus 2. Or 1 minus 2 is just a negative. Okay, just a negative. Negative, if we put a negative here, we can calculate it like this. So 54 times 2 raised by 5 times 2 to the 6 minus 1. Because if you put negative here, you see the 1 becomes a negative, but negative 2 raised by 6 becomes positive. All right, so the rest you may use a calculator to calculate this. Okay. So let's see B. Expand this logarithmic expression. Right. So this now is only one log with the numerator with the denominator. So remember the terms in the denominator becomes negative. So basically we'll have 3 log base 2 of y plus this square root indicates half log base 2 of x minus 1. That's the numerator, right? Denominator will have minus log base 2 of z. Then minus log base 2 of y squared plus 1. And that's it. We cannot split y squared plus 1. So we have 1, 2, 3, 4 logs. Because here we have 2 in the numerator, the product of two things. Where the denominator is also product of two terms. So I have 4 logs. Okay, 5 is the last question. So 5, we want to verify this trig identity. So when we verify, we start from one side, we end up at the other side. So this one, we will start at the left-hand side. So the left-hand side equals to secant square, let's split secant square x divided by secant square x. The minus 1 divided by secant square x. Secant square divided, that's 1. Well, 1 minus secant square becomes cosine square, right? Because 1 over secant is cosine. Well, sine square plus cosine square equals 1. That means 1 minus cosine square equals to sine square. Well, that's right-hand side. So it's verified. Right, we started from the left-hand side, we end up at the right-hand side. So we have verified his identity. Okay, that's it. That's the last recitation.